Okay, now here's a name you won't have to remember again. Varignon's theorem. However, what it is talking about is an extremely important thing. What it says is that with respect to any point, the algebraic summation of the moments of the components of a force must equal the moment of the original force. Of course, that's all gobbledygook, right? So another way to say it is, if we have a bunch of forces acting on a body, then their effect, like all those forces, is the same as a resultant force. So one force that has the same total moment as a group of forces. So let's look at this and really see how it looks. So here we go. Here's a parallel force system. And we have force 1, we have force 2, we have force 3. So that's 3 forces. And the overall external effect on this particular beam will be the same as this resultant force, which happens to have the same moment around there. So if we add up all the moments of F1, F2, and F3, they will have the same moment as that guy. And that resultant force will have the same force as F1, F2, and F3 added together. So they have the same moment total, and they have the same total force. Same total moment, same total force, but we've all condensed it down into a single spot. Okay, now how would you figure this out? Because there's this guy right here. We don't know where this resultant force would need to be placed. Like, you would be given these most likely, but you wouldn't necessarily know what that distance is. Well, it's honestly not that difficult, because I kind of gave it to you when I said the total force is the same and the total moment is the same. So, first off, we would add all of our moments together. This M stands for moments, and the subscript O, that just tells me what point I'm taking the moment around. If I take it around this point, that part was called C, you would see some of the moments around point C. I can actually choose any point I want, but why not some moments around O? Okay, so what we know is that our resultant vector, resultant force, times its distance from that, which we don't know, will be equal to the sum of all the other moments. And we can then solve for that. However many moments we have, we just sum all those moments, and then we divide by our resultant force to get that value x. And in case you forgot, that resultant force would be the sum of all the forces. Now, since this is a parallel force system, all of these forces are parallel, which makes things easier. There's no components. I could do the exact same thing, though, if I had a force, that was at an angle, or even multiple forces at angles. I would just break it all into components. And I have to determine, okay, which component of that resultant force do I actually need, because it might be like this now. I would only need the vertical component because this distance is in the horizontal. I only need the perpendicular component. Okay. So I know this might not make a lot of sense right now, but the big thing is, all I'm saying is that in the end, if you want to condense everything down, a bunch of forces into a single force, it's got to have the same total force, and it's got to have the same total moment once you place it down. Okay? Otherwise, you're not keeping it the same. You have to keep it the same. You can condense it, but it's got to have all the same functionality. So, thank you for listening, and now that you've seen this one, why don't you take a pause and go and check out those example videos so you can see these problems done and see how you can really succeed in these. Okay, with that, this will be the end of the section. I'll see you soon. Bye-bye.